Welcome to Darasa Online. Dear students, I'm Mr. Novatus Gabriel Moyo, a chemistry teacher, and today I'll be presenting to you a Form 2 topic known as oxygen. Specifically, I will base on the subtopic known as preparation of oxygen, and also I will discuss on another subtopic known as uses of oxygen. So, you are most welcome. So these are the two subtopics that we shall discuss today. One of them is preparation and the properties of oxygen, and the other one is uses of oxygen. So let us now start by discussing on preparation and the properties of oxygen. Dear student, you remember that we discussed to the last lesson. Today we shall be specifically discussing on chemical properties of oxygen. Dear student, what are the chemical properties of oxygen? Do you remember some of the chemical properties of oxygen? Now today we shall be discussing one after another. One of the chemical properties of oxygen is that oxygen reacts with the metals to give metallic oxides. This is the first chemical property of oxygen. Oxygen reacts with metals to give metallic oxides. When these metallic oxides are dissolved in water, they form what is known as basic solution. The other chemical property of oxygen is that oxygen reacts with nonmetals to give acidic oxides. So, oxygen we are going to discuss these two in details there after a few minutes. Also, the other chemical property is that oxygen supports combustion, dear students. You know what is combustion? I think you read it when you were in Form 1. So oxygen supports combustion. It supports burning of substances. It's because oxygen burns some fuels, but itself it does not burn. So that is the chemical property of oxygen. And when fuels are burnt by oxygen, they produce either heat, light, and energy. So oxygen supports combustion. The other chemical property is that oxygen is a strong Oxygen is a strong oxidizing agent, dear student. Why? It's because oxygen is more electronegative. It's one of the electronegative elements. So oxygen reacts by accepting some electrons. This makes it an oxidizing agent. So it increases also burning. An oxidizing agent increases burning. That is another property of oxygen. So these are some of the properties of oxygen. Now we are going to discuss the first two. Oxygen when it reacts with the metals to give metallic oxides. I will start by discussing on this one. Reactions of oxygen, reactions of oxygen with metals. As I said before, dear student, oxygen reacts with the metals to give metallic oxides. It reacts with metals to give metallic oxides. When these metallic oxides are dissolved in water, they form a basic solution. Metallic oxides, sometimes known as basic oxides. Basic oxides. And when metallic oxides are dissolved in water, they give basic solution. Now today we shall be discussing some of the examples of metals that can react with the oxygen to give metallic oxides. I will start by potassium. This is an example of a metal, potassium. When potassium reacts with the oxygen, it produces potassium oxide. So potassium reacts with oxygen to produce potassium oxide. Now, dear student, potassium reacts with the oxygen by forming a lilac color flame to give potassium oxide. Potassium oxide is a white powder. So this one here reacts by burning with a lilac color flame. Now let us go and see a lilac color flame. How does it look like? Dear student, this is a kind of a flame whereby potassium burns in oxygen. So when potassium is burning, it forms this kind of a flame with this color. This is a lilac flame of burning potassium with the oxygen. So when potassium is burnt with the oxygen, it burns with this kind of a flame. This is the lilac flame. Let us now see another metal. The other metal is sodium. Sodium also, as a metal, it reacts with the oxygen to form sodium oxide. So sodium reacts with oxygen to form sodium oxide. Sodium reacts with the oxygen to form sodium oxide. When sodium is burnt in oxygen, it burns with a yellow flame. It burns with a yellow flame. So this one burns with the yellow flame, and it produces white crystals. You get white oxide. These are crystals of sodium oxide. Let us now go and see the color of sodium when it's burning. And this is the yellow flame that I was talking about. So you can see it. You can differentiate it with the other one, which was a lilac. Sodium burns with a yellow flame to form an oxide, which is white crystals. Let us now go and see the other metal, magnesium. Dear student, magnesium burns in oxygen to produce magnesium oxide. So magnesium burns in oxygen with a bright white flame. It burns with a bright white flame to produce white powder of magnesium oxide. Let us now go and see this kind of a flame. Dear students, you can now see this is a flame showing magnesium ribbon was burning. It burns with this kind of a flame. It is called a bright white flame. A bright white flame. And this forms an oxide known as magnesium oxide, which is powder in form. Let us now see the other metal, that will be calcium. So calcium burns in oxygen to produce calcium oxide. Calcium burns with a brick red flame. Calcium burns with a brick red flame, and it produces an oxide known as calcium oxide. Let us now go and see the color of calcium oxide. This is the color of a flame of calcium. You can see it. This is the brick red. It's shown by brick red. So I think now you are in a position of differentiating the colors of burning metals such as calcium with that of, can differentiate with that of magnesium. You can differentiate with that of sodium, and you can also differentiate with that of potassium. So you should be able to know these different colors. And dear students, this brick red color is used as a confirmatory test for presence of calcium. We have some other metal like copper. Copper burns in oxygen to produce copper oxide. This one is copper oxide is black. It's an oxide which is black. So copper, when it reacts with the oxygen, produces copper to oxide. This one is black. It's a black solid. And a frame is always a blue frame. A blue frame. I think now there are some other metals that you can go and read them and give out their colors. We have metals like zinc. When it reacts with the oxygen, it gives out zinc oxide. You go and find the colors of an oxide and a flame color. We have metals like iron. You should go and work on these metals, on their colors, flame color when they are burning, and the colors of their oxides. Now, dear student, as I said before, that all those metals I've given examples when they are burning in oxygen. When they burn, they produce acidic oxide. They produce metallic oxides. And the metallic oxides produced, when dissolved in water, they give out basic solution. And this can be tested by putting a litmus paper in the solution of those basic solution, whereby these kind of oxides, when dissolved in water, they produce basic solution which turns lead litmus paper to blue. That is the concept that you should have also. Now, after saying that, let us try to see the reaction between oxygen with the nonmetals. The reaction between oxygen with the nonmetals. Reaction between oxygen with nonmetals. Let us have some examples of nonmetals. Nonmetals like sulfur, and carbon. Now, dear students, when nonmetals react with the oxygen, they form acidic oxides. So the reaction between nonmetals with oxygen produces acidic oxides or non-metallic oxides. So the reaction is nonmetals with the oxygen to produce non-metallic oxides, which are acidic in nature. These nonmetals, these non-metallic oxides are acidic in nature. And when the non-metallic oxides are dissolved in water or reacts with the water, they form acidic solutions. They form acidic solutions. That is the concept also you should have. When non-metallic oxide reacts with the water, they produce acidic solution of these non-metallic oxides. And this acidic solution turns blue litmus paper to lead. So this turns blue litmus paper to lead. Now let's have an example of this. Let's have an example of this. Let's have sulfur with oxygen. It produces sulfur dioxide, sulfur 4 oxide. When sulfur reacts with the oxygen, it produces sulfur 4 oxide. But it is said that sulfur burns vigorously in oxygen. It burns vigorously in oxygen with a blue flame to produce harmful, irritating, and choking fumes which are white in color. So sulfur burns vigorously in oxygen with the blue flame to produce harmful, irritating, choking, white fumes of sulfur dioxide. That is the concept on this nanometal with oxygen. Let us now go and see this kind of a blue flame. This is the gas jar. You can see within the gas jar there is a deflagellating spoon with sulfur. Now sulfur is burning, giving this bluish color. You can see this bluish color of the within the gas jar there is a bluish color which has been caused by sulfur burning, producing this bluish flame. So this is the way sulfur burns, that it burns vigorously to give this bluish flame. Let us have another example, dear student. Another example is carbon. When carbon reacts with the oxygen, it produces carbon 4 dioxide. Carbon dioxide is also an acidic gas. Carbon dioxide is also an acidic oxide. It dissolves in water to give acidic solution of the acid known as carbonic acid. Therefore, carbon dioxide is usually tested in the laboratory by turning lime water milk. So this is also another example of a nanometal. So with all that I've discussed on the metals and the nanometals, now let us go and see what can be the chemical tests of oxygen in the laboratory. How can you test oxygen in the laboratory? Dear student, oxygen can be tested by lowering a glowing splint into a gas jar containing oxygen, whereby it will rekindle or it will relight a glowing splint. So by lowering a glowing splint in a gas jar containing oxygen gas, whereby a glowing splint will relight or it will rekindle. Let us now go and see this kind of test in the laboratory. We can see it here. Now class, let us see a chemical test of oxygen in the laboratory. When a wooden glowing splint is lowered into a gas jar or a conical flask containing oxygen, that wooden glowing splint it will rekindle or it will relight. You can now see this is the glowing sprint. It was taken and lowered in this conical flask with oxygen. You can see the flame. It has now relighted a glowing sprint. Thereafter, after discussing that, I would like to say to you students that we have discussed the chemical properties of oxygen and the tests of oxygen, but you should remember that in the process of preparing oxygen, there are some chemicals that are not advised to be used in the laboratory. Chemicals like potassium permanganate and oxides of mercury, they are actually not advised to use them in preparing oxygen. It's because they are toxic and harmful. So these are actually not advised to use them in the laboratory. Now I want to discuss with you something about the uses of oxygen. Dear student, as you know that oxygen is an essential gas in the earth. It is an important gas to me, to you, and to all living organisms. Therefore, oxygen has the first use, which is in breathing and respiration. Let's start with respiration. In respiration, oxygen breathes or burns food so as to release energy. It's that energy which makes me now see me here, I'm talking. It's that energy that makes anybody or any human being or living organisms or animals to either to move or to conduct their physiological activities. So respiration for burning food to produce energy. One can ask himself, how? Where do we get this oxygen? The oxygen that we use in the respiration process is from the surrounding, is from the plants. Through the process known as photosynthesis, we do get oxygen. It is this oxygen that burns food to produce energy. Now, let us see in breathing, oxygen is used to patients. Maybe a patient who is in coma, who cannot breathe properly, is supplied with the oxygen, which is always stored in cylinders. They are found in hospitals. You can now see this is the patient. He's being supplied with the oxygen by using the breathing apparatus. So he's getting oxygen in hospitals. This oxygen, you can see the pipes bringing in, or the apparatus bringing in oxygen. This oxygen is stored in oxygen cylinders. So patients are supplied with oxygen through breathing apparatus. But also oxygen is used by divers. Deep sea divers do use oxygen. You can now ask yourself why deep sea divers use oxygen. It's because there is lower concentration of oxygen in water. Therefore, deep divers should go with oxygen cylinders so as to be supplied with the oxygen for their respiration activities in their body. Now let us go. We can have an example of deep divers. You see, this is a diver. He is or she is in a deep sea. This is the oxygen cylinder. This is the oxygen cylinder he is carrying, and it is supplied within the special apparatus. So now he can breathe properly. This is also another use of oxygen. See, can see it properly. Cylinder, apparatus. Now the person is breathing properly in deep sea. Also, oxygen is used by mountain climbers. Dear student, mountain climbers do use oxygen. You can ask yourself, why oxygen to mountain climbers? It is because at high altitude there is low concentration of oxygen. This is from the concept that oxygen is denser than air. Therefore, when you go to high altitudes, the concentration of oxygen decreases. Therefore, mountain climbers requires to have oxygen cylinders to support them in breathing. So mountain climbers at high altitude, there is low concentration of oxygen because oxygen is denser than air. Therefore, mountain climbers, we are talking of mountain climbers, require oxygen gas for breathing support. Now, dear student, you should be very much careful that not every person goes to the mountain requires an oxygen gas cylinder. Sometimes there are some people who are physique, so they can climb up to the peak of the mountain without having this supply of oxygen. Now let us see. Can see these are Tanzanians. They are at the peak of Mountain Kilimanjaro, but they are not carrying the oxygen cylinders. So it depends with the physique of a person. But if your body is somehow weak, so there is emergencies for supplying with the oxygen from the oxygen cylinders. So when you go high to the peak of the mountains, because it's on high altitude, there is low concentration of oxygen, so someone requires oxygen support for breathing. Also, oxygen is used in welding. Oxygen is used in welding. Dear students, oxygen is used in welding of some metals, maybe in cutting. It can be in cutting. This is from oxygen ethane flame, which is about 2000 centigrade. This is used in welding. You can now see, this is an example. Someone is welding, is doing a process of welding, is using oxygen in this process. So it can be used in melting metals, cutting some hard metals, and many other activities. So there are some other uses of oxygen, such as in burning, because it supports combustion. So oxygen, you can now see substances are burning. It's through the support of oxygen because it supports combustion. We also have some other uses of oxygen, such as in rockets. Oxygen liquid and hydrogen are used to propel rockets engine. This is the other use of oxygen. Also, oxygen is used in making different chemicals, such as sulfuric acid. This is made by some components of oxygen. And then now there are a lot of uses of oxygen. So dear student, you can now add some more. Let us now go and see some questions on these two subtopics. Let us see question number 1. Question number 1 says, Janet lit 2 charcoal stoves. She put a tin gallon whose both ends were removed to act as a chimney to the first stove, while the second stove was left open without a tin chimney. She allowed the charcoal to burn for 15 minutes. In which stove did the charcoal burn first? Why? This is the kind of the question that can be asked. That this Janet had 2 charcoal stoves. One had a chimney and another one had no chimney. Now, dear student, in a question like this, you should be very sensitive and see what is being asked. Here, one wants to show the use of a charcoal chimney in correction of oxygen, in increasing the concentration of oxygen to charcoal. Therefore, a charcoal stove with a chimney will burn very fast because there will be high concentration of oxygen within that chimney. While the other one, oxygen, air is just passing through it, and there is no much more concentration of oxygen. This is how you can respond to this kind of a question. Dear students, I think this type of concept we have discussed it. We discussed the reaction between metals to produce metals with the oxygen to produce basic oxides. What would happen if it reacted with the carbon? If it reacted with the carbon, it would produce carbon dioxide, which is an acidic oxide. It will produce a non-metallic oxide. Now, dear student, let us now go and see question number 3. Question number 3A. What will happen when a glowing sprint of wood is introduced into a gas jar containing oxygen gas? Roman 2. Hydrogen gas reacts with the oxygen. When a glowing sprint of wood is introduced into a gas jar containing oxygen, a glowing sprint will relight or it will rekindle. And when hydrogen gas reacts with the oxygen, hydrogen gas reacts with the oxygen, it reacts sometimes explosively, it produces water. So water will be formed. And B, what are the 4 uses of oxygen gas in our daily life activities? What are the 4 uses of oxygen gas in our daily life activities? You have now seen, dear students, from the discussion, we have several uses. It is used in breathing, it is used in respiration, it is used in welding of metals, it can be used in different industries, in chemicals, such as making sulfuric acids. So there are several uses. You can add some more uses. There is a question there. Match the following statements with the correct words from the box. Burn in oxygen to produce an acidic oxide. It alters the speed of a reaction but remains chemically unchanged. It burns with a lilac flame. Its oxide is white solid. It burns with a dull red flame. We have Roman 1, potassium, metals, calcium, nanometals, catalyst, decomposition, and the zinc. Now I'll try to respond on some few of them. Others you will respond by yourself. So burn in oxygen to produce acidic oxides. These are nanometals. It alters the speed of a reaction but remains chemically unchanged. You remember we discussed this when we were discussing on a catalyst. So this should be a catalyst. Its oxide is white. It burns with a lilac flame. Class, you remember this, you have to respond by yourself. We were discussing this. This is potassium. Its oxide is white solid. You go and define this. It burns with a dull red flame. You also go and define this. We have question number 5. As a chemist, explain briefly how you do differentiate an ordinary air from pure oxygen. This also is the kind of a question that you should go and try to perform, but you should go with the knowledge of knowing that this is pure oxygen and the other one is ordinary air. So you find some literature and see how you can differentiate these ones. Dear students, now let us go to question number 6. The question states, a student was assigned to carry out a chemical test for oxygen. A. Suggest one chemical test which can be performed by the student. B. Briefly explain 3 chemical properties of oxygen. Now, dear student, this is a kind of a question that can be asked, that a student was assigned to carry out a chemical test for oxygen. You have to suggest one chemical test which can be performed by the student. Now you remember, dear student, one of the chemical tests I told you that when you lower a glowing splint into a gas jar containing oxygen, it lights a glowing splint. Now you can find another test. Dear students, question number 6b says, briefly explain 3 chemical properties of oxygen. Now this you can go and perform as an assignment. Let us go to question number 7. Question number 7 says, why is oxygen important to the following groups of people? Explain briefly by giving one reason in each case. You have the cases: A. Mountain climbers, B. Deep sea divers, C. People dealing with cutting metals and welding. Now, dear students, why is oxygen important to the following groups of people? To the following groups of people. Now let us start with the A. Mountain climbers. Why do mountain climbers need oxygen? Dear students, you remember I said oxygen is denser than air. Therefore, when you go higher in high altitudes, there is low concentration of oxygen because oxygen is denser than air. Now, mountain climbers require oxygen for breathing processes. So the reason behind it is because that in high altitude there is low concentration of oxygen. That's why mountain climbers require oxygen cylinders when they are climbing their mountains. This is the way that you can respond to such kind of a question. Now, why is oxygen important to B. Deep sea divers? Dear student, that is another area. Now it's for deep sea divers. Dear students, you should remember that when you go into water bodies, within water bodies, there is a less concentration of oxygen. It's because oxygen found in water is dissolved oxygen. Most of the oxygen found in water is dissolved oxygen. And deep sea divers do not use this kind of oxygen. Therefore, due to low concentration of oxygen within water, that makes these deep sea divers to go with oxygen cylinders so as to support them in breathing. So this is also the other use of oxygen by these deep sea divers. Let's see another one, which is, why is oxygen important to people dealing with cutting metals and welding? Dear students, people dealing with cutting metals and welding require oxygen in the process of cutting or in the process of welding. It's due to the fact that oxygen do make what is known as oxygen ethane. Oxygen ethane is a very hot flame which ranges about 2000 centigrade. Therefore, this kind of a hot flame is used in cutting different metals, and it is also used in welding. It is also used in joining metals and several other uses. So these people require oxygen very much so as to perform their cutting metals activities or welding activities. So this is the way you can respond to such kind of a question, and you should go and find some more books so that you can get more knowledge on the use of oxygen. Now, dear student, we have some references that you should pass by and get some more knowledge on chemical properties of oxygen. The first reference is Chemistry for Secondary Schools, Form 1 and 2, 2012, Oxford University Press, Tanzania Limited. The other one is Holderness A and the Lambert, 1969, a new certificate chemistry, 4th edition, Henman Education Book Limited. And the last one is Lion L, 2016, Chemistry for You, 5th edition, Oxford University Press. So you go and pass through these references. I'm sure that they will help you. Now, with that, students, I hope that we have covered a lot on the properties, especially the chemical properties of oxygen in the laboratory. You are now in a position of responding on these chemical properties and explain them with examples and even with some demonstrations. We have covered also on the uses of oxygen. Now, dear students, keep on watching Darasa online. Stay with me during the next lesson. Thank you very much.